Today we will discuss about the cyclic amides. Cyclic amides are also called lactams. See here, beta lactam, gamma lactam and delta lactam. What is beta lactam? See here, here 1, 2, 3. 3 carbon are here. This is alpha carbon and this is beta carbon. And this carbonyl group is attached to alpha carbon and this NH group attached to this beta carbon. So we will call beta lactam to this. Why? Because at beta carbon NH is here. Now here see gamma lactam. This is 4-member ring. This is 5. Gamma lactam is 5-member ring. Here 4. This is 4. This is 5 and this is 6-member ring. Okay, but number of carbon count from here 1, 2, 3, 4. 4 carbon here 1, 2, 3, 4. Right? 4 carbon here. In this case 6-member ring. Here 1, 2, 3, 4, 5. 5 carbon. So although 6-member ring, but since nitrogen is also present inside the ring, that is why in total we will call that it is 6-member ring. This is 5-member ring and this is 4-member ring. So this 4-member ring amide group is present, then cyclic alkane it is beta lactam, and then this is gamma lactam. Okay, amide, cyclic amide. This is cyclic amide, this is also cyclic amide. Amide groups are present in the ring. So carbonyl group as well as NH group both are in the same ring. Now we will discuss about reduction of cyclic amide that I told you, type of alpha, beta, gamma, delta that I told you lactams, reactivity of these lactams and ring breaking in the presence of nucleophilic reagent, role of temperature during the time of reduction of cyclic amides by LiAlH4 or AlH3 or any other reducing agent, and cyclic amides are called lactams. We had discussed this. Now I will tell you how. See why it is happening, why it is reduced very easily. This ring is 4-member ring, it is highly strained. So it is highly reactive for the reduction as compared to this, So it means this is reactivity this will be more higher than this will be higher than this. When it is subjected to any reducing agent or any nucleophilic reagent, so this will react faster as compared to these two. Now, it is highly reactive. They are very strained. 4-member ring open easily in the presence of nucleophilic reagents such as CH3-MgBr, LiAlH4 or acetylides, etc. They can be break very easily. Now how they are breaking? Now I will tell you this. See here, I draw all these 3 structures. Take a pause and draw all this first. Pause to your camera and then take this picture and then we'll discuss. Now this is beta lactam, this is gamma lactam. I told you this is alpha, beta, gamma. Gamma carbon attached to NH, so it is called gamma lactam. And this is alpha, beta, gamma and delta. This is delta, so we'll call it delta lactam. So in exam when they will ask what happens when gamma lactam reacts with LiAlH4 or CH3-MgBr or any other nucleophilic reagent, at that time need not to be worried about it, because you know that it is cyclic amide. Okay, 5-member ring is there, 5-member ring out of 5-member. Here you see 5-member ring, so 4 carbon is there and 1 NH there. Here if it is 6-member ring, so 5 carbon is there and 1 NH is there. Here 3 carbon chain and 1 N is here. Now on reduction, ring will open. This will open from here. Okay, so this now again numbering is very important here. 1, 2, 3. Write on 3. As I told you here, write on 1, 2, 3. And at this 3rd carbon you have to write on NH2 group. And in first carbon, in state of carbonyl group, you have to write on CH2H group. In all these cases, you have to do like this. See, this is 1, 2, 3, 4 carbon ring. So write on 1, 2, 3, 4 carbon. And that the terminating carbon you have to write on NH2, and the initial carbon you have to write on CH2H. Okay, in all these cases, first carbon is bearing CH2H and last 4th carbon is bearing NH2 group. CH2NH2, because it is CH2. So when it will break and 1H will coming over here, and here 2 H and H will be coming over here. So you will get, what will get? 1 degree alcohol and amine, 1 degree amine. So but ring opens, that's it. And both the alcohol group and amine group are present in the same chain. Now see, they are present in the same ring. After ring breaking, they are not, they are in contact. Not from here but from the chain, long chain. See, I have written here CH2OH, CH2, CH2, NH2. Now there is no, second opening is, they are not shaking hand from here. They are, okay, we are friends, but here they are breakdown. Now here CH2OH, CH2, 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 NH2. Right? This is first carbon, and you have to count carbon. 1, 2, 3, 4. Right? So means one nitrogen is missing over here because nitrogen is coming over here. So you are getting amine in this carbon and amino group in this carbon, and this 1 degree alcohol group, and this is amine. Okay, so this is very easy. You can do, easily you can do. See, 5 carbon chain. You can write on, and the first carbon you write on OH group, and in the 5th carbon you have to write on NH2 group. Do you get my point? It is very easy to understand. So you have to name. This is 3 amino propane 1-ol. This is 4 amino butane 1-ol. And this is, you have to name yourself. This will be, tell me, 5 amino pentane 1-ol. Okay. Now I'll discuss different compounds. Case 1. We have discussed that only one ring is there, but now we are discussing there are 2 rings. Instead of one ring, there are 2 rings. Okay, so amide group present in the same ring. When amide group here present in the same ring, then ring opens. So there are 2 rings. One is phenyl group. Whether it is phenyl group or any cyclic group, cyclic ring, need not to worry about it. There are 2 rings here present, and CONR, that is amide group, is in the one ring, and then ring this will open. Okay, this linkage will be opened by LiAlH4, and you'll get CH2H and HR. If it is NR, you have to write on NR. If it will be H, you have to write on H, depending what is there. See here, one CH2, CH2. I have written CH2, CH2. So what does it mean? If it is N, so you are here only one H will be coming here. So it is 2 degree amide. 2 degree amine, sorry. 2 degree amine you will get. 2 degree amine and 1 degree alcohol. Clear? So 1 degree alcoholic group and 2 degree amine we are getting. So amide group present in the same ring, and here they are present in the same chain, but ring is open. Ring opening occurs, reduction to amine will take place. Okay, now the oxygenation of amide occurs, that we will discuss. Oxygen based group are better leaving group. 1, 2, 3 degree all amides can be reduced. So here this is general category, and we are discussing about the exceptional case. Okay, this is not belonging to this. This is belonging to the other group, which I have to tell you now, because I had written everything in one go, that this is not belonging to here. Only here you have to. This is a stop over here. Right now, reagent used. Here this part we are discussing about this, means that is temperature governed reduction. Okay, in temperature governed reduction, what will happen? This amide group, any amide, if it is a CONH2 group with aromatic amide, so at 0 degree C we'll get amine, and at high temperature we also get amine. So need not to worry about benzamide, we'll get definitely amine, 1 degree amine. But if it is aliphatic amide, see here I have taken aliphatic amide. So 0 degree will give you aldehyde, and high temperature will give you amine. That is very, very exceptional case. This is not, means you have to search so many books, then you'll get these type of questions. Okay, aliphatic amide, but will give you at low temperature, always you will get aldehyde. See here, CH3CONH2 I took, LH, 0 degree C, aldehyde. 2 carbon amide, 2 carbon aldehyde. 3 carbon, here 3 carbon amide, you will get 3 carbon aldehyde. That is, it is acetaldehyde, this is propanol. This is ethanol, this is propanol. But at high temperature, always, high temperature give you amine. Do you understand? 0 degree C, at 0 degree C, all aliphatic amides give you aldehyde. And at high temperature, they will give amines. So below 0 degree C means at least minus 15 degree C. Okay, so means below degree. 0 degrees. So you'll get aldehyde. But high temperature, at room temperature, always you will get amines. So now we'll do aromatic amide. Aliphatic amide, you understand? Now aromatic amide. Earlier I told you that whether it is 0 degree C or high temperature, we'll get definitely amine. But stop here. When it is disubstituted amide, then at 0 degree C to minus 50 degree C, you'll get aldehyde. Clear? So that disubstituted amide behaves just like aliphatic amide, that it will give you aldehyde at 0 degree C, but at high temperature you will get amines. Right? Now we will discuss second case, which were I was giving you tips about this, that this tip I was giving you about. Now we are discussing deoxygenation of amide occurs. In which case this deoxygenation of amide will occurring when carbonyl group is converted into CH2 group. But it is also taking LiAlH4 minus 15 degree C. Then this C6H5CH2CON. See, this is external. Carbonyl group is external to the ring. So the ring will remain as such. There will be no breaking off in the ring. Here it will be coming CH2. That's it. CO group is converted into CH2. Draw all this. Pause your camera and take the picture, and then you learn it. Benzene rings, CH2, CO, and CH3. This is disubstituted amide. ALH3 minus 78 degree C. You will get CH2. Count the carbon. You see only target only CO. CO is converted into CH2, and rest you have to write on as it is. Here CO is converted into CH2. That's it. No need to worry no need to mug it up. Only you have to remember the temperature as well as which reagent we are using. See here, we are taking this CONCH3 minus 78 degree C, CH2. Okay, so carbonyl group is converted into methylene group. So this is called temperature governed reduction of amines. Now I'll tell you different thing. See, 1 degree, 2 degree amide on reduction does not give alcohol, as I told you that at which temperature? At very low temperature they will give you aldehydes, and at high temperature they will give you amine. And 3 degree amide on reduction can give you alcohol at very low temperature. So it will can give you aldehyde as well as alcohol also, but temperature should be minus 15 degree C. Now cyclic amide, here, see here in this case, here this is outside of the ring, so the ring breaks up and you'll get C6H5CH2OH, and this is in the ring. What is the difference between all these things? All these are temperature governed properties. See, when I am saying that this cyclic compound is there and this is outside of the ring, this is heavy bulky group, easily come out, and it will form, it will give you benzyl alcohol, and this. See, this is taught in very senior classes, but nowadays in IIT and CAT and MCAT exam and SET exams also, they are giving such type of reaction. That is why I am discussing it here. Otherwise in class 12th you need not to do it, but in IIT, yes, definitely you have to do this. Okay, so this ring and nitrogen is here, then everything is same. Here it will be breakdown and you'll get C, 2 carbon alcohol, and here this. So temperature, as I told you here, minus 15 degree C. So it will be breaking this and you will get amine. Here CON, draw this picture and you'll get 1 degree. This is again break from here, and 1 degree, this is 1 degree amine, this is 1 degree alcohol. This is not 1 degree amine, NHR group hai. This is 2 degree amine. Okay, so this is 2 degree amine, this is also 2 degree amine. You see, when 1H is there, you will are getting 2 degree amine. I think these points are clear to you, and need not to worry that how can we do it, mono-substituted, di-substituted, everything I explained you. Aliphatic amide and aromatic amide, we have discussed all these things. Okay? Take a look again, exceptional case, temperature governed, minus 0 degree C, you will get amines. In that only one, they are CONH2 group is outside, then we are getting amine. The CO group is converted into CH2, that we were discussing in the other cyclic compounds also. Disubstituted amide also, here aldehyde, and only at this temperature you are getting amines. Okay, so what does it mean? There is no cleavage, only this group is converted into CH2, that's it. And in case of this at 0 degree C, this is not converted into CH2. This will be cleaved and you will get aldehyde CH3CHO or PaCHO. Clear? See, that's it. And you divide it and you do practice, everything will be fine then. Thank you.